Okay, so today we'll be looking at transformation of processes as well as bioaccumulation of toxicants. Transformation of processes as well as accumulation of toxicant. But maybe we may not finish the whole lot of it because that's got about 50-something pages and I wouldn't want to rush through. It's important that we take time so that we understand each step of the way. By the way, this topic is very, very important because it gives us an insight of what happens to the chemicals. Oh, what is this now? Okay, it gives us an insight what happens to the chemicals, and we find that there are some chemicals that are less harmful from the point they are being released into the environment, and then maybe later on, we find that those chemicals, they become more harmful because of some processes they undergo, the transformations. That's why we're calling it transformational processes. So we need to understand these processes that are involved. Some of these processes, they are physical, chemical, and some of them are biological in nature. Yeah, then the other thing, you find that some of these processes, some of these toxicants.
Can't see the screen.
Oh, okay, I thought maybe I will be writing and then okay.
Oh, sorry, you want to start writing? Okay, no, it's fine then. I thought you were sharing something. It's fine then.
Yeah, because it involves some structures, or maybe during that time, that's when I'll be.
Okay, no problem. No, I thought you were sharing something and I wasn't just able to see.
Okay. You share. So maybe, but I was just trying to prepare the background. Yeah.
No, it's fine. You can go ahead.
Okay. Yeah, so I was saying that there's some toxicants that are so harmful from the time they are being ejected to the environment, but maybe a few days later, they degrade, they become less harmful. And I remember giving an example of having a garden at the backside of the yard. Then you find that the leaves are not growing that healthy. You buy some insecticides, you spray on the leaves, on the vegetables. Sooner or later, they'll give you after 1 week, the vegetables will be safe for consumption. Now, what happens to those chemicals? It is because those chemicals, they degrade. The concentration of the chemicals on the leaves reduce as the time goes. The reduction of concentration of the part of those chemicals, the reduction is a function of time. As time goes by, the concentration reduces. So we are looking at those processes that are involved, like I said. Some of them are physical, chemical in nature, and some of them are biological in nature. So from the beginning, we'll start looking at those that are physical, chemical in nature. So there's some few things that I'll be writing, and there are times when I will be just referring to the notes. Okay, yes. That's why I don't like sharing the screen from here, because at times it behaves. Okay. Yeah, so this is the information that we have. We're saying that following the release and transport into the environment. Okay, yeah, so we are saying that the chemical might undergo some abiotic processes. So we need to understand when you say abiotic processes and when you say biotic processes, what type of processes are they? Some of them are physical, chemical in nature, and others biological. Also, like the way I'd said, we're saying that some points I'll be skipping them because I've jotted down those that I feel are important. So maybe this point we go through, say, this is This is also known as the degradation or transformation of a compound. Remember what I said? When a compound is released into the environment, it undergoes some processes. Now, those processes that it undergoes may be classified as biotic, may be classified as abiotic. Okay? Then during that transformation, you're saying that the structure of the compound may change. This now will take us to some introduction of organic chemistry so that you understand when you say the structure of a compound has changed and how its properties change. Now we're saying when a compound or a pollutant undergoes those processes, two things are likely to happen. The concentration of that pollutant does not remain the same. So it's either the concentration reduces, making it that toxicant to be less harmful, or as it undergoes those processes, at the end of the day, we might produce the chemical that is more toxic. It depends on the processes that this chemical undergoes, as well as the environment in which those processes are taking place. That is what, that is the rationale I might give on this topic. We're saying that, so there's some two things that I'll be talking about, there's some two things that I'll be skipping out. Yeah, so here, this point may not be important. So saying transformation and neutralization, mineralization changes, physical chemical, this one's not important, but maybe I can just talk about that. It's just bad that the way this course is given, there are some few things that you may not have learned, yeah? Because when I was going through, I came across where they looked at the rate of degradation, the rate at which the concentration of a pollutant is changing, the rate at which the concentration of a pollutant is changing, that's what we call a rate of degradation. But now, the rate or the method at which this degradation is changing, there are those things you might have not done that you call the pseudo order, the first order, second order, third order, but I'll find a way of simplifying them so that we have a better understanding, so that we meet halfway. So we are saying that the changing of concentration of the toxicant may depend on one, the availability of the reaction. How many reactions is this chemical undergoing? So if you have compound A and compound B that are undergoing different series of reactions, if this one has less reaction that it has undergone, we expect to find the change in concentration different from this compound B that has undergone series of reactions. So you're saying that the degradation may depend on the availability of the reaction. Then the other one is saying that the degradation may also depend on the chemical, the intrinsic reactivity of the chemical. How much or how reactive is this compound? Because later on we'll look at some of the reactants, so some of the pollutants that reacts in certain ways, and also look at some that do not react in those ways. You may have pollutant A and pollutant B. This pollutant A can undergo a certain reaction that this pollutant may not undergo, depending on the structure of these pollutants. Then the other one is that even if these reactants, these pollutants can react very fast, are very reactive, it depends on how much reactants are there. Because these reactants are the things that these pollutants will be reacting with. Could be water, could be just chemical compounds. The availability of the things to react with will also determine how much change will be brought about within the toxicants. Now, we're saying that where they react, how fast they react, which we call the reactivity, what does it depend on? So it depends on the pH. We'll come and look at maybe not pH, temperature. How does the temperature affect the reaction? Light, because we also have to look at a certain process that involves light. Okay, we also look at redox. There is a certain process also that talks about the redox. Another one talks about light intensity. Then the other one talks about the concentration of the reactant. So these are the things that will speed up the change in the process. Okay, now, I talked about transformational processes being classified into two groups. There was abiotic and abiotic. So it is time and again that we need to understand them, because remember what I had said, there was a question which was talking about giving the biotic transformational processes of compounds, and we need to give examples of these compounds, and as well as the examples or names of these biotic and abiotic processes. So that's why I said yesterday with Madam Shatu, we said it's important maybe today we just have a look at these things, so that even when it comes to now approaching the question, we'll be using information that we're going to learn today. So speaking of biotic and abiotic, which one is it? So the abiotic process, this is a chemical breakdown of, but I would want maybe to disagree slightly with the breaking down. Maybe it's better if we could have said the chemical change, the chemical alteration of the pollutants. Because mostly when you say breakdown, we're talking about moving this substance from something complex, maybe something simple, but there are times we get to form something complex. We're going to maybe look at that later. So all the abiotic process is a chemical process. It's a chemical process, nothing to do with the biological stuff, nothing to do with the living organisms, nothing to do with the microbes, nothing to do with the bacteria. It is the chemical process. So we need to understand that from the word go, the abiotic process, this is a chemical process. At least we have one thing understood, abiotic processes. These are processes that are chemical in nature. And which ones are they? So the major ones that we're going to look at, maybe let me see if I can just increase the font of the pen. Okay, so we have the hydrolysis. The hydrolysis is something to do with water. And then we have oxidation, which is a major process. Yeah, and then we have the reduction, and then we also have photochemical. So remember, from the previous slide, I was giving an emphasis on the point which was saying that the reactivity of the reactant, how fast the reaction takes place, depends on certain conditions that are given us: the pH, the light, there temperature. And then I also said light will be talked about now in details, as well as water. So these are the four processes that we need to bring out when we are talking about abiotic transformational processes. So these processes that happen abiotically, we're talking about those four: hydrolysis, oxidation, reduction, and photochemical. Photons. We're going to look at how the light affects. Yeah. Then biotic processes, these are organic in nature because the breaking down of these compounds, they depend on the biological organisms, which we might look at microbes and other stuff. So we're going to look at this in detail. So this lecture is splitted into two parts. There's the first part which talks more about the biotic processes. Then the other one talks about the biotic. So if time allows, maybe we just look at this in details, then maybe talk about this less, or maybe just this one, and then we see how far we can go. Okay, so that is that. Now, do not mind that I've skipped much of the introduction in here because it's explained in slides ahead of us. So we may not look at that. So we say abiotic transformational processes or biotic transformation processes. So now that's where now they talk about these processes in details one by one. Okay, so now what is hydrolysis? The way we're going to approach this discussion today will be based on the toxicology that we are discussing. Certain things that I'll depict to be chemical in nature, organic in nature, I may leave them, certain things, because maybe we might have not have done a strong foundation linked to some compounds. So saying hydrolysis is a chemical reaction of organic compounds with water. Hydro. I'm sure Mr. Revius understands better the hydro part. My engineers are hydro. When we say hydration, is to do with the addition of water. Dehydration is something to do with the removal of water. So hydro in itself tells us more that water is involved. So one of the processes in that question, we have found hydrolysis. So it's important to explain what is hydrolysis. It's a chemical. Remember, this is a biotic, so we need to know that these processes are chemical in nature. It's a chemical reaction of organic compounds with water. And then we're going to understand how the chemical breakdown happens in the presence of water. We'll have some structures of certain compounds changing because of the presence of water. Now, I'm saying it's important that the introduction of hydroxyl group, these are the things that these guys were making the notes. Certain things they were not supposed to bring them because we may not understand them better. But hydroxyl, how the hydroxyl comes in, maybe the understanding that I might attach to this, I'll give you water. We know very well that water is H2O. Yeah, water is H2O. But the way this water is, the structure of water is drawn like that. We have oxygen and we have two hydrogen because H2, two hydrogens, so that's why I've got this one and that one. But during the chemical transformation, you will find that the likelihood of having one bond breaking. And when this happens, we're going to have hydrogen alone, a hydrogen, then we have OH. So OH, this part which is formed, this OH, hydroxyl. Because we're talking about water. So we have the water splitting that way having hydrogen alone, and then we've got hydroxyl, and then I'll come and explain where these two things go during the chemical transformation. Okay, now there's again this point here, which may be a little bit hard to understand when you say polar products, because the polarity of molecules may be a little bit hard to understand because maybe we have not done the geometry of molecules. So this point, I'll come and explain later when you look at the actual examples. But one thing we need to know is that a chemical compound which is reacting with water must be soluble. If it is insoluble, then it cannot react. Then there was this formula. Let me just go here. Yeah, there's this formula that they had written. Maybe let's see how much information we can get from that. They're saying DC. D is talking about delta, the change in concentration over change in time. DC, T. We're talking about how the pollutant gets to have its concentration changed. So we're saying that the change in concentration is a function of time. So dT over dt, we're talking about how it happens. So we're saying that dt over dt is a decay, dC over dt is a decay of concentration, the change, the drop down in concentration of a chemical compound that is undergoing hydrolysis. And the change in concentration is a function of time. But I think we may not even go much into detail, these things. But now remember, I talked about how the concentration is reducing. Is it by first order? We have second order, we have third order, and then also have pseudo first order, first rate. So we need to understand that the degradation of the chemical compound happens by pseudo first order or pseudo first rate of a chemical reaction. But this question, I think they cannot come because this is inclined to inorganic chemistry. Yeah, so these, they might not even bring them. These ones you can just cancel here. But it's just important to have an idea that the way the concentration of the pollutant changes depends on the time, how long it takes. Like I'd given an example of the vegetables. They'll say these vegetables are safe for consumption after 1 week. So you start counting from the time when we had sprayed the chemicals on the leaves. Okay. What else can we get from the next page? Yeah, so some few things, I'll just talk about them a little bit here and there, and then I just leave them. So this is the way the structure of compounds change when they're undergoing an abiotic process, which we call hydrolysis. Remember I said hydrolysis is the addition of water to a compound. Now remember, in toxicology, we don't do much of the structures. The question there in 2016 was just saying, give examples. But at times, just looking at examples, names, butyl acetate, it becomes hard to understand how the hydroxy we talked about is removed from water, getting to have hydrogen, also being separated from the water, and how that is done. That is the reason as to why they came up with this structure equation. They were just trying to show. So if the question just tells us to give examples, we don't need to go into structures. So one of the organic compound that undergoes hydrolysis is this ester. Now, by the way, an ester, when you hear of an ester, esters, hydrolysis of esters, what do we mean? Esters, these are organic compounds that, that have specific smells. When you go to Creamland, you want to buy ice cream, and then you tell them the flavor I want is vanilla. That smell we get from vanilla, that smell we get from spray, that smell we get from roll-on, those things are esters, they're organically made. I remember at some point I'd made like a vanilla flavor in organic chemistry. So I was just trying to help us understand that an ester is an organic compound that is able to undergo the process of hydrolysis. But now, like I'd said, when you say butyl acetate reacting with water to form acetic acid and 1-butanol, it becomes difficult to understand how that is happening. So that's why they came up with this, like I earlier indicated. Now, let me show you how the water gets to have itself divided, forming the hydroxyl group they talked about, and how the chemical structure of a compound changes. So you can have an ester. The R here represents the carbon and hydrogen atoms in a chain. Then we have carbon here, we have oxygen, and then we have another R. This is carbon and hydrogen, it's a chain, these are chains, okay? A group of carbon, hydrogen, these are in a very long chain, so just represented by the R. Then we are saying that water is present. Maybe I just have an illustration. So when you add water, we understand that that water, like the way I had drawn it, you're going to have it that way. And in the process, this part is broken. And this part breaks, as well as this part breaks. When this part breaks, we are going to have hydrogen coming to take the place where the R was. So we have R, C, that, O, H. So that is how the hydrolysis is taking place. We have one hydrogen coming to take the place of that. Now, once this goes out, we will remain alone, which will be added to the hydroxyl. And then you're going to have OH. So this is an acid, and this is an alcohol. This one is an ester. So you see how the structure is changing from an ester to an acid by the process of hydrolysis, because the water is added. Chemical breakdown. We are breaking down an ester to form an acid as well as an alcohol. So this is an illustration organically on how the hydrolysis takes place. So this is what was even demonstrated in here, where they had this hydrogen and oxygen containing molecule, the water, splitting, so that from here you're going to have OH, and then here you have hydrogen. This is an alcohol, the butanol is an alcohol, the acetic acid is an acid, then you started with an ester, which is butyl acetate, reacting with water by the process we call hydrolysis. But remember, like I said, this is coming from an organic world where much of such reactions are emphasized, but in toxicology, you don't do such reactions. So the question will just come for us to give examples of compounds that can undergo hydrolysis. So in the way we can present that, we can say esters can hydrolyze to form an acid and an alcohol. I think that one is better. An ester hydrolyzes to form an acid as well as an alcohol. That is how you can present that from the hydrolysis point of view. Then there is also some few things here that esters, where do we use them? Where do we encounter them? Such things are not really important. Then this is the same thing now. Instead of having an ester, it's another example. Another example of a compound that hydrolyzes. Remember, the first one is an ester. Then the other one is this one now, which is an amide. So an amide also, like the way I'd said, esters hydrolyzes to form an alcohol and an acid. What about amides? Amides hydrolyzes. An amide is able to hydrolyze to form an alcohol and an amine. Oh, sorry, to form an acid, not an alcohol, to form an acid and an amine. So this is an amine. This one is an acid. This is an amide. There is a difference between amide and in an amine, you have only nitrogen and hydrogen. On amide, there is the presence of that. So 2 examples of compounds that can undergo hydrolysis. 1, ester, 2, amides. Yes, then the organophosphates are these ones. No. You need to have a little bit of background on organic organometallics. That's when you can understand them better. Now, remember what we said. I said that some pollutants, I gave examples of A and B, that some pollutants, pollutant A may react to certain condition or may undergo a certain reaction that pollutant B may not. So they're saying among other organic compounds, some of them may not react with water to form hydrolysis. And among them, that's where we've got alkanes, we've got alkenes, the benzenes, the biphenyls, we have the polycyclic aromatics, PCB. Remember what we said about PCBs? Among the properties is that this is insoluble in water. It can't dissolve much in water because the reaction with water is hydrolysis. It gives us a reminder of what we did the other day. Now, I bet to disagree on these ones because esters are able to undergo hydrolysis. That is one of the examples that we just did. Ketones, you may not understand also these ketones, aldehydes, these ones, we just remove them. Yeah, but these guys do react with water. So it's important to maybe just give these examples. Among those that cannot react with water, PCBs, which is among the polycyclic aromatic compounds, the biphenyls, the alkanes, as well as the alkenes. These are homologous series of organic compounds. And there are some compounds that react with water very fast, but these ones here, they do not. The next page is talking about, so we are done with hydrolysis. We are done with hydrolysis. 2 compounds, amides. Amides, as a reminder, amides to form acids and amines. Then we also have esters to form acids and alcohols. 2 compounds that we've looked at so far. Then The second process is called, under abiotic transformation process, is called oxidation. Now, the process of oxidation is described or is defined in 3 ways. The oxidation process is described or defined in 3 ways. And among those 3 ways in toxicology, they just talked about 1 of the 3. So that's the one we're going to focus on. Now, I'm remaining with, I think 1 hour, 30 minutes. Oh, sorry, not 1 hour, 30 minutes. 1 minute, 30 seconds. Is there a part that I've rushed you through that I need to overemphasize on? Hello? Mr. Revius, are you there?
Yes, Mr. Kunda, I'm following. I think I'm okay on my end.
Okay, Madam Shatu, because I think we have only a minute, so they'll need to end this session. If we still have time, we go to the other session.
Okay, it's okay.
So we go to the second session.